Hi guys, it's Mrs. Williams. So I want to go through this AP problem with you a little bit. I know it's a really old one. It's from 1986 AB4. It's ancient. But nowadays, these type problems are only part of an AP problem. They don't do an entire problem on this topic anymore. So I wanted to do a problem that was all on the topic we're using. So that's why it's an old problem. It's not that it's not good information. It's just it used to be you'd have a whole problem on continuity, and then you'd have a whole problem on related rates and a whole problem on area. Now they mix it up. So it's in part A, part B, part C. They're all different concepts. Okay? So that's why sometimes I go back to the older problems just so we can focus on that one particular topic. So here we are, 1986 AB4, no calculator. We let f be the function defined as f of x equals that piecewise defined function where a and b are constant. So now they're telling us in part A, if a is 2 and b is 3, is f continuous for all x, and justify your answer. Remember, justify, you have to be very precise, you have to prove everything. So the first thing we're going to do is we're going to look at what is this function if a is 2 and b is 3. Well, then f of x would be the piecewise defined function, okay? Now, you know what? Look at this piece here, this absolute value of x minus 1 plus 2. That absolute value of x minus 1 is shifted this way so that the vertex is at 1, which means then when we're on the x is less than 1, we're on the negative slope. So this is the negation of x minus 1 plus 2, which is really just negative x plus 1 plus 2, or 3 minus x, or negative x plus 3. That's when x is less than 1. Now the bottom piece is where we have the a and the b. So the a is 2x squared plus b is 3x, and that's for when x is greater than or equal to 1. Now, for the x's less than 1, we have negative x plus 3. That means f of x is a polynomial. It's linear. And all polynomials are continuous. So we know f of x is continuous for x less than 1. If we look for the x's greater than 1, f of x is a quadratic, which is also a polynomial. And is also continuous. So the question is, do the two pieces meet when x is 1? So our problem area, or possible problem area, is x equals 1. So the first thing is, does f of 1 exist? Well, if we're using x is 1, we're on the bottom piece of the function, so it's 2 times 1 squared plus 3 times 1. That's 2 plus 3, or 5. My function exists. Yay! The second thing is, does the limit exist? So let's say we use the limit as x heads to 1 from the left of our function. Now, if we are to the left of 1, those values of x are less than 1, so we're on the top piece of the function. And if I do the substitution, that's negative 1 plus 3, or 2. If I do the limit as x heads to 1 from the right of f of x, if we're to the right of 1 on a number line, those x values are bigger than 1, so we're on the bottom piece of the function, 2x squared plus 3x, and when we substitute 2 times 1 squared plus 3 times 1, we're going to get 5. Now if you look at the limit from the left and the limit from the right, they are not equal, which means that the limit as x approaches 1 of f of x does not exist, and therefore f of x is not continuous at 1. But it is continuous for all x not equal to 1. have all the information we needed for that. Awesome. Now there's a part B. Now notice in part B, it says describe. That means we're not going to find the actual values for A and B. We're going to have some kind of equation that relates A and B. So we're going to describe all values of A and B for when f is a continuous function. Now, we know that the function exists at 1. The problem happened when we looked at the limit as x approached 1. So if we look at the limit as x approaches 1 from the left of f of x, that's when we had the limit as x approached 1, and we just did this earlier, of this absolute value of x minus 1 plus 2. You can go back to the original, or you can use the negative x plus 3. And when we substitute in, we get 2. When we do the limit as x approaches 1 from the right of f of x, we are on the other piece of the function on the bottom, which is that ax squared plus bx. And when we substitute in the 1, we're going to get a times 1 plus b times 1, which is just a plus b. Now, in order for these to be continuous, the limit from the left has to equal the limit from the right, and a plus b has to equal 2. That is my description. Do I know the value of a and b? No, I do not, because a might be 1 and b might be 1. A might be a half and b might be 3 halves. I have no idea. All I know is their sum is 2. All right, guys, off to the next part. See you soon.